if you could add world-leading, low-power, long-range Wi-Fi HaLow to almost anything just by adding a USB stick? Meet the MM8108-EKH19 Evaluation Kit. This kit is designed to be the easiest way to experience our world-leading flagship MM8108 Wi-Fi HaLow chip, all in a versatile and compact USB form factor. Whilst this kit does come with an off-the-shelf, high-performance Wi-Fi 6 travel router from GL-MT, the main star of the show is the USB RD09 Wi-Fi HaLow USB dongle. With this USB form factor, you can add Wi-Fi HaLow to anything with a USB port, providing long-range connectivity to your product or project, all without the extra hardware effort. The RD09 itself is built around our best-in-class MM8108 Wi-Fi HaLow chip, delivering up to 43.3 megabits per second at 26 dBm max output power. We have worldwide support for operation. With a Type A USB 2.0 interface at one end and an SMA antenna connector at the other, you can bring both your own HaLow antenna and your own host. On our GitHub and the Morse Micro forum, we provide support for porting with ready-made OpenWRT build targets for over 20 plus third-party routers from popular brands such as Asus, Netgear, Linksys, TP-Link, GL-MT, and others. For the hobbyists out there, it even runs well on the Raspberry Pi 4, and we even have support for OpenWRT running on Linux virtual machines with our x86-64 target. So instead of having to invest many dollars and hours in RF redesign, PCB respins, and enclosures, you can just plug in our RD09 USB with a small software port on any OpenWRT capable device. Ports can be as little as 20 plus lines of codes, and our open source team is always willing to accept pull requests. It doesn't always have to be OpenWRT either. We're constantly working on new ways to improve integrations into other products. Now for the unboxing. Inside the box, you'll find everything you need to get started. The quick start guide with some additional information. Then you'll find the star of the show, the RD09 Wi-Fi HaLow USB dongle. You'll also find an antenna, the Wi-Fi 6 travel router from GL-MT, a modular USB power supply with plugs for the US, the EU, Great Britain, and Australia. And finally, an Ethernet cable. On the RD09 itself, you'll find a 5-volt USB-C port for powering the device, 2 Ethernet ports, and the USB port which will host the RD09 USB adapter. Following the quick setup on the quick start guide, you'll attach the Wi-Fi HaLow antenna to the USB, plug the USB into the slot. Once you have your RD09 plugged into your GL-MT router, you can power it on. From here, we'll plug in an Ethernet cable to get set up. For ease of use, we have matched in our software the details on the sticker of the device, and you can log in and navigate to the IP at 192.168.8.1. For ease of setup, we also allow you to connect to the default 2.4 GHz Wi-Fi AP. Today, we'll just be using the Ethernet. Once you've plugged in your USB-C power adapter, you may have to wait for about 40 seconds until the light on the front of the GL-MT3000 goes solid blue. This shows that the host is booted. From there, you can turn to your computer and navigate to the address on the sticker. That'll be 192.168.8.1. At the moment, we've defaulted to having no password on the device, but this will likely change as cybersecurity requirements increase in the future. Once you've logged into the device, navigate to the wizards. You'll be shown the option of setting it up as a standard Wi-Fi access point or station, as well as 2 different types of meshes. For today, we're going to follow the simple access point setup in the quick start guide. Starting with the standard Wi-Fi HaLow, I'll be quickly greeted by the landing page. From here, depending on which region I'm in, whether that's the Australian region, Canada, EU, Great Britain, or the US, as well as Japan, I can set that in this page. From there, I can change the host name and even set a password if I'm security conscious, but for the moment, we're just gonna leave it as is. Once those changes apply, we can select access point again on this page. From here, we can set up the HaLow network. For the moment, again, I'm gonna leave it as the default SSID and the default Wi-Fi password, as is shown on the sticker. But for width and channel, these channel values would vary greatly depending on which region I've chosen. For the moment in the US region, I'm going to choose Auto, which uses a special automatic channel selection. From here, I'll be greeted by the upstream network page. This is where I decide how I want to connect to the larger internet or my existing isolated network. For the moment, given that we're just testing with HaLow, I don't want to connect to any other internet, and I will select none. And here's the magic of this kit. We see that there's a 2.4 gigahertz access point and a 5 gigahertz access point on the device. We are co-locating this with our HaLow network, and by keeping the credentials the same, it will allow other capable devices like other equivalent EKH19s to roam between the different networks, providing us the best throughput at different ranges. For the moment, I'm just going to go through and click next. At the end, I'll apply those settings I'm using. At the moment, because we're an access point, we've got the various HaLow 2.4 gigahertz and 5 gigahertz access point cards. These will show us the different connections as they're made to our device. To demonstrate a 5 gigahertz connection, I'm going to use my phone to connect to the 2.4 or the 5 gigahertz access point on the device. By scanning the QR code on the back of the device, because I've left the credentials default, I should easily make a connection. As you can see on the homepage, I've gotten connected to the 5 gigahertz network produced by my EKH19. My phone has been assigned an IP address and I can see my hostname. Now to connect to the HaLow access point. Just as an example of the versatility of this USB setup, I can show you some devices which I quickly ported to use Morse Micro OpenWRT and the USB RD09 dongle this morning. This is an Asus AX1800 Wi-Fi 6 router, which I now have added HaLow connectivity to. This is another similar consumer router, the Netgear Nighthawk, which I've added HaLow connectivity to inside the USB port. And for the more tinkering side of things, I've simply added it to the Raspberry Pi. All these build targets you see before you are already supported on our OpenWRT Morse Micro GitHub. For today's demonstration, I'll show you just a simple, quick setup of the speed, the HaLow speed and range which we can get using an EKH19 and a ported router between the RD09 dongles over a HaLow connection. As a demonstration of the HaLow connectivity provided by the RD09 USB dongle, I'll do a quick demonstration of the throughput I can get by connecting from the Asus router and running an iPerf test against our existing EKH19 device. To start, I'll disconnect the Ethernet cable from this device and plug it into our Asus router. I'll then take this EKH19 and move it to a location at least 2 meters away from my other device. Now that I've ported the device and I've loaded that software on here, I should be able to access the Morse OpenWRT interface at the default IP, depending on the build target. I know that the build target default IP for this device is 10.42.0.1. I'll access that now. From here, just like with the MM8108-EKH19, I can log into the device. From here, I can go through the same process as I did with the EKH19, setting up a Wi-Fi client this time. Here, I'm scanning for other Wi-Fi HaLow networks, selecting and following the wizard. Because this device will be acting as a client, I do not need the access point, and I'll hit apply there and wait for the configuration to apply. With my Asus device, with the USB RD09 HaLow dongle plugged in and the ported software running on the host, I can now access this device at the default IP address for other EKH devices. Here, you see I can navigate to 10.42.0.1 and I'm presented with the exact same login screen as I was with the EKH19. Again, by default, there is no password and I can log in, but you can set that later in the system commands. From here, I'm going to go to Wizards. And again, I'm greeted with the same 3 options between 2 meshes and a default access point or station. I'm going to select that option and set up my device as a client. When I click next, I'm greeted with the HaLow network, which I want to connect to. I can scan for existing HaLow networks. And from here, I can choose from the list, but based on the EKH19 access point, which we set up before, I know it's this one. It's got the same password as is on the sticker because we left the credentials default. Again, I'm going to set the traffic mode to none because we're just doing an isolated HaLow test in this example. For the moment, I'm going to leave the 2.4 gigahertz access point off, but I can use that to connect devices like my phone to the Asus router and get onto the HaLow network provided by my EKH19. Click next again and apply those settings. From here, my Asus will be connecting to the Wi-Fi HaLow network provided by my EKH19 using the RD09 dongle. your solution to Halo connectivity. Navigating back to the home page, I can now see in the corner that I am a Halo client, and on the Halo uplink card, I can see that I'm connected. To quickly test this connection, we provide a simple tool called the range test. Under the services submenu, you can select range test, and other Halo devices which are capable of range test can be automatically discovered. In this case, as soon as I loaded the page, I saw that my EKH19 with the hostname GL-MT3000 has appeared. I'm going to select that device. From there, I'm going to input the password to that device. This is the system password, but at the moment, from there, because the device has no system password by default, I can leave this field blank. I can add a description if I'd like to do, ASUS demo, and I can even add coordinates if I'm testing outdoors. Finally, the most important box is the range test. For this indoor range test, I've moved the device a very short distance away, so I'm going to put 10 meters in the range box. I can choose which direction and which protocols I'd like to test with over the Halo network by clicking the gear icon. Today, I just want to do a quick test of UDP, and I've chosen the send direction, which means that traffic generated by the iPerf underneath will be sent from this device to my EKH19 AP, and I'm going to run a short test for 10 seconds. I'll save that configuration and simply press start test. This tool is designed to be a low-touch way to evaluate the throughput and range of your device. As you can see, as the test completes, I should get some values at the bottom. I can see the status of my test, which completed, the time, the host which it was tested against, in this case the EKH19 AP, and the description, as well as the distance, and most importantly, the throughput. In this case, we got 27.68 megabits per second throughput of UDP. I can also see the operating bandwidth, the channel, and the signal strength which was registered. I can also download the summary of results if I do more tests, and I can also choose to delete this if I want to. That is a demonstration of how simple it is to add Halo with our Morse Micro OpenWRT ports and our RD09 USB dongle to any device and get it up and running and connected to existing Halo networks, as well as functioning with its normal 2.4 gigahertz and 5 gigahertz access points as usual. The MM8108-EKH19 Evaluation Kit with the star of the show, the RD09 USB MM8108 Wi-Fi HaLow USB dongle, shows just how easy it is to get up and running with Wi-Fi HaLow development. The compact USB form factor means that you don't have to do any hardware redesign. You can do fast bring-ups on any device that supports OpenWRT, with more support for other hardware integrations coming soon, and add long-range connectivity to your device just by plugging it in. Suited for smart cities, industrial communication, agriculture, or even home Internet of Things projects. This kit is the easiest way for hobbyists all the way through to network engineers to add next-generation networking to your project. Visit morsemicro.com for full documentation and GitHub links. And for tips and tutorials, don't forget to subscribe, like, and join the Morse Micro community forum where innovation connects.